I think it can be argued that the reflectors are angled like that. Maybe the dust would slide off down there like a slippery dip or something. But still, the tracks themselves, the boot tracks, they would all be covered up by this stage, I reckon.
Yeah, those reflectors, they're not smooth surfaces. They've got little holes because they reflect the light hitting them on a prism system. But also, the other point, you see a lot of photographs of rocks with no dust on them at all. Random rocks somewhere on the moon, allegedly. No dust on them at all. If they've been there for a few million years, you'd think they'd be covered in a bit of dust by that point. But no, you can read the letter C on one of those rocks. Oh dear, oh dear. Come on, NASA.
I have the earliest release of that photograph.
I was pleased to see you'd followed that particular line of investigation to its conclusion. It was a very good piece of analysis because
Mhm.
that photograph appeared, what was it, 1 or 2 days after it was released?
It was originally released on May 1st, 1972. That was the earliest printing of the picture. About a week later, they got rid of it in some of the releases. Interesting. That shows that they must have noticed it and acted fast to try to get rid of it.
You know
Yeah,
what? It's just the same as that Battle of Los Angeles. When they're showing that UFO in those spotlights, one guy went back to the original negative. He got it from the New York Times. And guess what's in that negative? Nothing. The newspaper editors added that in there, and that's why it's in there. He showed the two. He showed the original, and then he showed the one that little thing was added. But in the original, there is nothing there. Nothing. So it just goes to show you what they can do. Same with this Apollo business.
yeah.
It's no different.
It was the origin of fake news, wasn't it? Back in, was it 1952, those photographs above Washington?
I've been very, very concerned by what's available at people's fingertips. We did some examples just on the last show with all those AI generated images.
Yeah, but it's right. Look at the astronauts, what they could do.
It's astonishing by what's available at people's fingertips right now. People can use all these AI programs to bring images to life. They can use deepfake technology to replace a person's face. We can fake a person's voice nowadays.
I don't think people are going to understand that the KH-4 is a specific version of the Corona satellite program. So,
Yeah.
yes, these images that we're showing are from the Corona satellite. It's the same thing, it just had a different version number. There was KH-3, KH-4, KH-4 Alpha, and KH-4 Bravo. That ended in 1972. The high resolution and mapping and surveillance was from 1962 to 72. So that's where they get that from. But it is the Corona satellite. And we have to be pedantic about that because these guys will not stop. They will claim that the KH-4 is a different satellite just because it has a Bravo or an Alpha behind it. So
Yeah.
we just have to get that out there.
And also, let's just say that KH in the description of many of these satellites stands for keyhole. That's all it stands for. And it's a series of satellites. I think we're up to about 20 now or something like that. KH 11 and 12 were the most recent ones that I was aware of. But there've probably been some since then. Because they keep launching the damn things from Vandenberg. They have to launch them from Vandenberg because that's how you get into a polar orbit, not an equatorial orbit where you launch from Florida.
The advantage of a polar orbit, of course, is that it'll cross the poles, both poles, and the Earth is rotating underneath it. So eventually you'll start to photograph the entire surface of the planet.
That's right. But if you launch from Florida, you'll only get one strip basically around the equator or up and down from the equator. You won't get the northern hemisphere or the southern hemisphere, not in the detail you might want it. Oh, talking of recording, Robert, I watched the reply to Digital Dave last night. Brilliant. Now, when I saw the lunar rover moving, I thought, what the hell's going on here? And the astronauts jumping up and down. I thought, bloody hell, I haven't seen that on film before. Oh, it's Robert doing his stuff. That's what it is. That might cause a few complaints. People say we've been manipulating stuff.
I remember when Bart Sabirel first received that video footage from NASA, and he would start doing interviews on radio shows and TV and whatnot. I remember he would be asked, "You're a filmmaker, Bart. Is this something that you could fake yourself?" And his reply would always be, "There's no way I could have faked Neil Armstrong's 1969 voice or a 1969 appearance." That answer wouldn't cut it today because of all this AI deepfake voice morphing technology we have today. Again,
Yeah.
it's very, very scary.
But this gets you get back to this Corona satellite.
Yeah.
These images, though, I mean, it's ridiculous looking. And I understand they're putting it in a PDF format. I mean, if you could get the original negatives from that satellite, I wonder if the photographs would be clearer. I would
Well, the
assume they
ones I
would.
found are straight from the NRO website. Yeah, National Reconnaissance Office, that's the one, yes. It was straight from the National Reconnaissance Office's website. So, like I said, so I assume these are first generation. These wouldn't have been, photographed off TV screens and released to the public as they did with Lunar Orbiter back in the day. So I assume we're seeing first generation. And if that's first generation, well, my golly, look at that. Leaves much to be desired.
But then, how did they recover the film from the Corona satellites? Not the Hexagon, that was dropped out and caught in big fishing nets behind aircraft.
Well, I believe the earlier ones did the same thing, but it wasn't until the Discoverer 14 mission that they first got the films back. The other ones had one problem after another with the films getting lost or camera getting jammed with the old acetane film. As I said, it wasn't until the 14th flight that they first got the films back.
But certainly with the Hexagon, I know that it was a big deal that they dropped them out of space and caught them in fishing nets behind aircraft.
Yeah, yeah,
Flown
they did the same thing with the earlier Discoverer or
out.
Corona satellites as well.
Yes, in the PDF, they're showing the plane with a net behind it.
It's interesting if these early ones were unpressurized, because that would imply that they would have to take this unpressurized film and then put it into a pressurized container just so it can survive the re-entry,
Well,
which seems to be more convoluted than it should be.
as soon as it's dropped out of the spacecraft, it will get into pressurized atmosphere. As soon as it
Yeah.
gets down to about 50 or 60 miles, the atmosphere is pressurized. But that's probably why they had to pressurize it. They discovered that pressure caused a major problem on photographic film.
Okay, wait a minute. The Corona satellite,
Yeah.
how fast was it orbiting at? Because if it's dropping those cans and it's doing 17,500 miles an hour, why doesn't it require a heat shield?
I thought they had heat shields on them.
Well, they do have heat shields. What I'm saying is that they would have to transfer this film from this unpressurized system into the re-entry capsule and then jettison that. And it seemed on the Hexagon Spy Satellite, they all had it all ready to go because it was already pressurized to begin with. That's what I was saying here.
But the
So
Hexagon Spy Satellite images are much clearer.
exactly. So that's because it was sealed from the beginning. It was sealed from the get-go, pressurized from the get-go.
Yeah.
The pre-Hexagon ones weren't apparently, and I think a picture says 1,000 words in this case.
Yeah. If the pre-hexagon satellites were flying at only about 100 miles up, there wouldn't be that much reduction in pressure. Well, there'd be some, but
Actually, it says the pre-Hexagon ones were up to 800 kilometers, so it's even less atmosphere up there.
yeah, that's quite high. 800 kilometers. That's above where the Hubble is now, or what was.
I looked that up. ChatGPT was saying that when the Corona came down over Russia, it was 100 miles when it was taking the pictures.
I'm looking at it right now. It says the apogee is 805 kilometers
Yeah.
and the perigee is 186 kilometers. So that's probably what it's referring to.
All right.
Yeah.
Yeah, could be.
Yeah, that would make sense why the images are so grainy. I think that's probably solar particles reacting with the film.
Like I said, it could be a combination of the two, the vacuum damage and the radiation damage.
But you
Yeah.
see, here's the thing. Dark Fen and the other fella here, they don't mention any of that. They just say the images were taken, but they don't show you them and say, oh, no, they're grainy or they're foggy or they're particleized. Right? They won't tell you any of that. And neither will Dave McKeegan. So,
Jay Windley does something similar when it comes to the Zond 5 mission. He often likes to argue that the Zond 5 flew turtles and wine flies, bacteria, and plant seeds and whatnot around the moon, and they all survived. Oh, yeah, that means humans can survive. Well, saying that humans can survive a flight to the moon simply because turtles can survive it, that's like saying that humans can survive exposure to the vacuum of space because water bears can survive it.
Yeah.
Turtles are much more resistant to radiation than humans. It takes something like 80,000 Roentgens versus a few hundred for a human.
It's a point they always miss. They don't get the comparison between species. I mean, cockroaches survive nuclear explosions, we're told.
Yeah.
Humans probably would have a problem with that, as we discovered.
Yes.
We're very delicate little creatures. We've got to have a lot of protection to ensure that we can survive in those environments.
yeah, I wonder if false teeth would survive there. So, Jarrah, we had a question by a viewer, and he was wondering about the Voyager probes, especially Voyager 1, since it's been out there the longest. I was wondering, Was there a battery in that craft? Because I was wondering with the RTG, did it have to have something like a power source in order to dump the voltage into that battery? Or was it just an RTG period?
It didn't use batteries, it used a radioisotope. In the outer solar system missions, because they're so far away from the sun just appears as a little star, so solar panels wouldn't cut it, and of course batteries wouldn't cut it either because they would die much sooner. So for the outer solar system missions, they tend to use radioisotopes, these little miniature nuclear power stations, and so long as the radioisotope lasts, it'll keep powering that thing until that thing dies.
Okay, now what about solar panels? Did it have solar panels of any kind?
No, it did not, but the Juno spacecraft had solar panels. That was a unique case in which they had to enlarge the solar panels such that they would get much more flux than they would otherwise get. But of course, with Juno, all it really had to power was just cameras, the instruments, and of course the communications to send it back to Jupiter.
You see, what the problem is that a lot of people are claiming that Voyager 1 and 2 are fake, that they're just nonsense because of what this Michio Kaku has come up with, claiming that it's having contact with aliens. This was the latest video that he had put up. Now, I don't know how much contact that he's claiming that it had, but this is the type of nonsense that is making people believe that this is fake. Now, we have to also go over the power source of the radio communication system because I believe it was 1 watt to 5 watts that it was outputting at about 2.45 gigahertz.
I've been a bit concerned about some of the things people have been saying about the wattage, not just with Voyager, but also with Apollo. There's been some claims that have been going around on the internet claiming that Apollo couldn't have transmitted the video signals from the moon to the Earth. Well, that's a bad argument to be making because the example they like to use is handheld or movie cameras, or TV cameras, I should say, that people use for shooting a scene of a news report or something for production, and they want to transmit the signal to the station. The transmitter has a battery the size of a brick, and it only goes a couple 100 feet. Well, the problem isn't in the power source. The problem is in the medium that it's transmitting through. Because as the signal travels through the atmosphere, the radio waves, they get absorbed, they get reflected, they get refracted. All this, it gets mitigated 6 ways to Sunday until there's nothing left. And of course, out in space, you're not going to have that issue because, well, there is no air, there's no atmosphere. And so, as long as you're in line of sight with the radio signal, with the radio transmitter, whether it's on the moon or out by Jupiter or Saturn or wherever else in the outer solar system, as long as you're in line of sight with that radio transmitter, you'll be able to receive the signals from it. All you need is a very large dish and have your receiver tuned to the correct frequency, the signal that it's transmitting on, and you'll be able to pick up the signal. And in fact, there have been people, amateur radio operators, who have received signals from Voyager. Most recently, there's this article here I'm looking at in Hackaday. Amateur radio operators detect signals from Voyager 1. And they show the readouts that they got. The example that I've cited before, there's a fellow in Portugal called Luis Cupido. He has a whole website documenting all his various detections of various satellites and space probes from all the different planets they visit, and Voyager 1 is among them.
Okay, now, but just wait. If Voyager 1's that far out, how can a guy with a dish in his backyard pick up the radio communications from this Voyager 1 when it's so far out there?
Well, again, you need to have a large enough dish to receive it and make sure it's tuned to the correct frequency. You'll be pretty much good to go. Since there's no air in space, signal can travel infinitely far. It may be somewhat quieter because it expands at the square of the distance.
Then again, when you look at the way radio waves work, it's no different than sunlight. It's just in a different spectrum. Now, we receive sunlight from stars all over the galaxy. We receive sunlight from stars in other galaxies. In fact, we receive light from galaxies themselves that are very far away. So, again, why wouldn't we be able to receive radio signals if radio signals are just a form of light in a form of radiation? So, that's my point.
There's an analogy that we like to use in astrophysics. We like to use the analogy of a bucket in a rainstorm. A telescope, be it an optical telescope or a radio telescope, it's just like a bucket in a rainstorm. The larger your bucket, the more water your bucket will collect. And in this case, it's not rain we're collecting, it's the radio signals or the light waves and stuff. And so, it's literally a case of all the better to hear you with, essentially. I would like to add another thing. I remember when we were on the live stream, some people were asking about the pictures that it was transmitting and how it could have done all that sort of stuff. Well, First of all, they stopped taking pictures after it left Neptune simply because the spacecraft, well, has got nothing left to photograph. It's out at the heliopause now. There's nothing really to see anymore, so they don't use the cameras anymore. Originally, what they wanted to have on Voyager is they wanted to have the same system that they had on the Lunar Orbiter probes, in which they had the camera with the SO243 film, which would be developed on the actual spacecraft itself, then scanned and then transmitted to the Earth. But I think they decided not to do that way because, well, by the time we'd get out to Jupiter, even at 100 rads to fog it by 50%, the film would probably have been destroyed by the time it got out to Jupiter. And of course, you can only use film once. So what they used instead was they used a Videocon tube camera. And they had a analog to digital converter aboard, which would then basically take the signal and record it to magnetic tape. And so basically it would store all the images on the magnetic tape. And once it was in a position to transmit these signals back to Earth, you see, because the camera can actually record the pictures at a much faster rate than the transmitter can send it. So the idea was they would record all the pictures of the outer planets onto tape, and then the spacecraft would play the tape back and transmit it to the radio tracking stations on Earth. In those days, you see, right, because color cameras were very huge, you would have like three different vacuum tubes, one for your reds, one for your greens, one for your blues, and they would be composited together to make a color signal. That would have been too heavy on a spacecraft. So what they used was they had a color wheel system on the Voyager. It was essentially, for all intents and purposes, a black and white TV camera, but it had a color wheel in front of the tube, I should say. And so basically what would happen is the color wheel would spin and basically as light's shining through it would record it multiple times. So, okay, we're seeing the signals in different shades of gray. We've got a color chart we can use and we can reconstruct the image that way to create a color picture. That's what NASA claims they did to get those color pictures of the outer planets.
Yeah, and that's what Tim Trumbull was saying too, the way that he used to do it. They did everything in the grayscale, and then they would do it that way on the optical printer, and then they could tell exactly what was going on, and with the colors, the hues, and everything else. But the thing is that when you get to this probe, now we're talking about pressure inside of that container with the film because the Corona satellite didn't have it, as you were saying before, but this one does, I believe, 1.2 something psi of nitrogen.
I believe that's the Hexagon Spy Satellite that used that. But as I said, the Voyager, they didn't use film because it wouldn't have made a difference had it pressurized or not. By the time you get out to Jupiter or Saturn, the film would be completely destroyed by the radiation. And so you'd want to use a video camera instead, a television camera instead. And so what I assume they did was they basically recorded all the pictures of Jupiter to the tape and its moons, and they would transmit it back to the Earth. Then it presumably would erase the tape and basically start over again to take pictures of Saturn. And in the case of Voyager 2, do the same thing with Uranus and Neptune. But the film cannot be.
Right. So then it would take images with the Vidicon tube with the color wheel spinning so that they could tell the shades and the colors. And then what they would do is they would store that on tape, turn the craft around, and then transmit it back to Earth.
That's correct, yes. They would transmit it back to the Earth via the tape. It was transmitted at a much slower rate than the camera could record, you see. I've got the numbers right here. The maximum data rate is around 115,000 bits per second. Okay, this rate it would take 43 seconds to send an entire image back to the Earth. But now the data rate is only around 160 bits per second, meaning it would take over 8 hours just to transmit one image. On top of that, the Voyager is now 23 billion kilometers away, so that it would take about 21 hours to reach us. And so that's basically the idea. So because of the distances away and the differences in the speeds of what the transmitter can do, what the camera can do, it's best to just record everything to storage and then transmit it that way. Transmit it after the fact once you've got the antenna in line of sight with the Earth. Even on the more recent missions, they did that on Galileo 2, where they had the Galileo probe while the atmospheric probe was entering the atmosphere, it was transmitting signals to the orbiter, and the orbiter would store everything onto its onboard storage. I believe in those days they probably would have used a hard drive or something. They might have used tape, I don't recall. It was the 90s back then, so they would have had some better storage technology by that stage. But the point is, the Galileo probe did the same thing. It recorded everything to its internal storage and then transmitted it to the Earth once it had a good line of sight to get the signal to Earth.
Right. Now, what about the hydrazine tanks that were on the Voyager 1 and 2 for the retro rockets to maneuver it? So then, how large would the tanks have to be that are holding that hydrazine?
Well, I don't recall the size of the tanks, but by and large, you wouldn't have to make that many movements because by and large, it gets most of its direction from the actual gravity assist maneuvers that it takes when it flies by Jupiter and Saturn and the other planet, called a slingshot maneuver. The idea is as you get towards the planet, it starts to speed you up and then it swings around the curve of the planet, changes the orbit a little bit, and the idea is the planet continues on its orbit and suddenly you've lost all your gravitational grip on the planet and boom, you swung out further off into space.
Yeah, that brings to mind another question. We're told that these probes are landing, for example, on these asteroids, and yet these asteroids, some of them are traveling at 35, 36,000 miles per hour, and yet the probes are only going at 26, maybe 27, 28,000 miles an hour. So how are they catching up to this?
In most cases, it's just a flyby.
You see, here's the other question that people are asking is how does it catch up with it in the first place when it can't match the speed?
I haven't looked into that question before, but the idea in general is to basically time your launch. You see, we have what's called launch windows. The idea is to time it such that, okay, this trajectory will take it within reach of the target body in question. And fortunately, in the case of most asteroids which we're getting sample return missions from, is they're very, very small. What that means is it doesn't have much escape velocity, these asteroids. In fact, you could literally reach escape velocity in most cases just by running or jumping off these things. Okay, and so it doesn't really take that much effort, so to speak.
So when they're launching it, it would be kind of like the moon. You would be launching it to where it is going to be, not to where it is. So that's
Correct.
probably how they're catching up with it then, because they're actually a little bit ahead.
There's a film that came out back in the 90s, Deep Impact. You might remember the scene where they're all on the comet, rather, trying to plant the nukes to blow it up. They all have all these cables anchoring them to the surface. That's actually a legitimate method of trying to land on a planetary body that's so small, the size of a comet or the size of an asteroid. They're so small that they just use harpoons to hold them to the surface. I believe the Philae did something like that when it touched down on the comet.
You see, this is the question I'm getting quite often is how are these probes making it, even getting there in the first place when they're only going at 27,000 miles an hour, and yet the asteroids are going at 35, 36,000 miles an hour. And I would think that it's because they're launching it to where it will be and not to where it is right now.
Correct.
Yeah.
You launch it to where you expect it to be in a certain place. That's why when you see all those textbook diagrams of the trajectory of like probes to the outer planets or trajectories to comets or whatever and stuff, it always seems to fall around the curvature of the sun. It's basically put into a solar orbit that will take it within reach of the target body in question. And such, once it encounters that target body, its trajectory will be altered by that object, by the target body's gravity. So that will put it into a position where it could potentially enter an orbit if it fires its engines in the forward position to slow it down such that it enters an orbit, or if it's just doing a flyby, the trajectory will be altered by the gravity of the asteroid or the comet or whatever it is it's targeting. And again, as I said, because these bodies are so small, you don't really need a lot of energy to get it to escape velocity or to get it back off the surface of these worlds because they're just so tiny. They just don't have enough gravity to keep it restrained to the surface.
And then there was another question about the PLSS pack. We're talking about a 386 watt battery that they were using at 29 volts, I believe, 24, 29 volts for Apollo 17. That pack apparently was out there for 8 hours. It could last for 8 hours, oxygen, everything in that pack. Now, I was looking at it and I believe it's called the sublimator. And inside the sublimator, I'm noticing that when they need heat going through all of those tubes that they have in their suit where there's water or coolant, whatever, going around, we would have to change and it would have to heat them up pretty darn fast when they're going into the shade. We know heating elements. You turn on a toaster or anything, I don't care what it is, that is going to drain that battery pretty darn fast. And then you have the pumps. Then you have the solenoid coils. And we know how current thirsty solenoid coils are. But the worst of it, I would think, would be the circulation pump for that water, or whatever they're using, and especially the heating elements when these guys are getting cold. I mean, that's going to just vacuum that current away to nothing.
I don't know about the battery and the plus, but I remember Rene had an entire chapter in his book basically trying to calculate the amount of water they would need to keep the astronauts cooled with this system. They had a liquid cooling system which would channel the water through these long johns they wear under the suit. And then, as you said, that would go through the sublimator where it would be jettisoned outside. He reckoned that they would need something like 20 kilos of water to last them. Now, granted, on the newer missions, the shuttle and the ISS, rather than rejecting the water, they recirculate it back into the suit, and the thing's built like a thermos bottle. It has a vacuum layer, so the sun's heat can't get into the suit. All they have to worry about then is the astronaut's own body heat. It makes you wonder.
Yeah, because the PLSS pack has a 16-volt battery in it at 386 watts. So that's only going to give you about 24 amps. Now, when you add all the pumps and the solenoids, that's not going to last too long, is it? And they claim that they're out there for 8 hours. See, I don't see that happening. Now, I understand that there was another battery for the communications up at the top that wasn't running off of that same battery that the coolant system and all that was running off of. But still, that's a smaller battery that's up there in the PLIS radio pack. How the heck could that last?
Here's the Wikipedia article regarding the thing. They say the lunar surface EVA first 4 missions was 4 hours with oxygen stored at 1,020 pounds per square inch, a 279 watt hour battery. That's what they said they had. And on the later missions, it was a 390 watt hour battery.
So again, it depends what article you read. I was reading in a NASA PDF that it was 360. Now it's 390. Well, it doesn't matter. I mean, that's here nor there. I guess we would have to look at the radio battery, the one that was operating the radio itself. That's going to be the kicker, that one. Because I don't believe that that battery is going to last 8 hours out there transmitting. And these guys were transmitting, talking to each other all the time just between the two astronauts. Never mind it going back to the LEM and being retransmitted like a repeater back to the Earth. I mean, that doesn't count. But when these guys are talking back and forth and back and forth, that's a different story because, that battery's going to be used up pretty quick. That was another question that came up. Even though it's supposedly on the lunar surface, these guys are carrying 180 pounds on their back. Well, divide that by 6. That's pretty heavy. So if you're going to lean back to take an image or a photograph of something, you're going to tip over. That's what I would think. Of course, you're going to take the camera off your chest like we see them do all the time because they're not going to be leaning over taking images of the Earth like that. It isn't going to happen. But anyways, I digress. But as far as the Voyager probes go, there's so much disinformation out there as well.
There's been a lot of disinformation I've noticed that's been popping up. Like, first of all, with this whole aliens thing, right? There's no thought about the probes encountering any aliens just yet because as at the heliopause, there's nothing. The closest star system is about 4 light years away. Okay, and it's only at the heliopause. It's not going to encounter any life forms for thousands of years. If it does encounter any life forms, I know they have like a video disc, gold record, I think it was called. They had the sounds of all these different languages, people saying hello to the aliens. And even the pioneers, they also carried something similar. They have a plaque with a man and a woman raising a gesture. There's a good meme on the internet. Dear Earthlings, please stop sending unsolicited news with directions to your house. It's creepy. Signed, the aliens. It's a joke that's going on the internet right now. But yeah, they actually have those kinds of messages aboard the spacecraft, but there's no realistic expectation of them being found by a intelligent civilization for thousands of years. We'll be all long dead by then. Better it to be a mystery than to be wrong.
Well, an alien spacecraft could fly by and see this probe and then just say, oh, we're going to take a look at what this thing is, and then just take it into their ship and then tinker with it. But then again, the scientists, they have instructions on how to play that disk. Would they be able to decipher that? That's the whole thing. So they're using mathematics, a lot of that, to try to get them to think about how to put this together.
It's essentially a glorified vinyl disc for all intents and purposes. It plays the same way. When they designed the thing in the 70s, that was the most up-to-date thing they could get to record all this data to the thing, such that it would be, last all this turn of time to get there, hopefully. That's assuming that it survives all the impacts with the micrometeoroids and whatnot. There'll probably be a lot of disk skipping, I guess. But getting back to some of the comments that have been said in the chats and also in the live stream, there was one comment I noticed, comments on the live stream, where some guy was claiming that the moon is made of plasma. I know where he's getting this nonsense from. There's some interview with this so-called scientist, his name is Foster, supposedly, who claims that the moon is made of plasma and that there will be never any landings on the moon or probes on the moon. Well, here's the thing, right? This was uploaded by the ABC. The ABC, first and foremost, they're the most reputable news source in Australia, but they also have their, shall we say, the funny side. They would like to dedicate certain segments to play some satirical clips. On 7:30, they used to have this one comedian, I forget his name right now, but basically he would interview his comedy partner, basically acting as the interviewer, and the other fellow would act as a politician or a celebrity who's basically made some notoriety in the current affairs, and they would basically do a whole piss take out of it, basically a joke interview. So, given the ABC has a precedence for that kind of thing, what I think happened is that maybe in the 60s they shot some satirical interview with this so-called scientist. It was intended for some comedy show that they were going to do. And, that's been filed away for God only knows how many years, and somebody's dug it up and uploaded it to the internet as if it's factual.
Yeah, it's really sad that people don't do a little bit more research and dig into it deeper. But these days, that just seems to be the way of things. Too much false information out there. Out there.